Yeah, that looks great. So let's start recording. So big welcome to Andrés Cruz, who is a adjunct instructor at Pacifica Catholic University of Chile. Teaches computational social science. And I was so happy to hear that he was open to my invitation to present, because he's got this new book out, R for Political Data Science, which is just really a really useful book for practitioners and teachers, and so I encourage you to check that out. But today we're going to be talking about Inixa. So thank you very much, Andrés.
Thank you. Yeah, I'm very grateful to be here. It's been great so far. I'm here to talk about this package I've been working on, which is called Inixa, an RStudio into supervised passive joins. And I'm going to explain the motivations behind it, then how it works, what it does, and I hope I can finish with a little bit of a reflection on what it says about reproducibility, I guess, or how it is connected to reproducibility. So I'm here to talk about joining data sets, which I'm sure is everyone's favorite task in data wrangling. And when you first learn how to do it, I think it's pretty outstanding. At least to me, it was a shock. Like, there's a better way than like getting two Excel spreadsheets next to each other and trying to match everything by hand. So you learn that there's a better way, and it's fascinating. So here I have two very simple data sets with South American countries and some variables. So let's imagine I want to add this B1 variable to this left-hand data set. I could do that with a variety of different things. With the R package dplyr, you could do a left join, you could use SQL and other R packages. It's really a widely used function. And there you go. It doesn't matter, they don't have to be in order. It's fairly simple. There are some other types of joins, of course. But yeah, it's great. When I teach these to students, they are always amazed by it at first. And then when they have to do their projects, and also when I work with data, so I work with observational data a lot, and sometimes with data that comes from web scraping, for instance. What happens is that variables are not standardized, right? So in this case, I have the same left-hand data set with the names in Spanish, and then I have the official English. So let's imagine that I have something like this one. Of course, a merge will fail because R will not know what to do, right? There's no way, even though for a human looking at this Brazil with an S and with a Z, it's basically the same. There's no way for the computer to tolerate. So this is a very common problem, at least to me. It happens to me like every week. So here I have another example. These are two decrees or executive orders in Chile about some region. We have 16 regions. There are not that many of them. And they're definitely not standardized. So this is basically the same one, and it's spelled differently. So imagine what happens in, let's say, counties, right? They're not properly standardized most times. So yeah, this is a very common issue. I know it happens in many disciplines. I'm used to working with geographical data or politicians' names, like all of these sorts of things. There are a lot of people working on this who don't have a standardization among their objectives, of course, because they're doing some different things. Here they are publishing decrees or laws, so perhaps they don't care that much about that thing. But when we want to work with these computationally, we require them to be somehow standardized, right? So what are the solutions? Power up itself, of course, is always a temptation. And I think we've all done it at some point, like maybe when you were first learning, or maybe when you're like you need to finish something quickly. Yeah, I don't think I have to explain this in this workshop why this is not a good idea. Definitely, it's definitely not reproducible. It's prone to errors. On my very tiny example before, there were only 4 observations, but what happens if you have like 500 in each, or I don't know, 1,000? That's not going to scale up well, right? So another thing that you can do, and this is better, of course, is you can use code to somehow recode the variables, right? And here I say quote unquote by hand, right? So for instance, you could use dplyr recode or case when or some other function that will help you. But you would have to look at the data set yourself and try to find out what's not working right. That would be what you would have to do. And maybe you would make mistakes, right? Another thing that you can do is you could create an ad hoc solution using regular expressions. And this is actually the correct answer in some cases, but it's usually very troublesome. Like you don't want to do this when you have like tiny data sets and you want to create an example for your class right before it starts. Or you can use approximate string matching, which I'm sure some of you might have heard of. I'm gonna briefly explain what this is. Even though well, okay, so this is the R package that implements it, string-dist. It provides tools to calculate distances between steps. So computer scientists have figured out different ways in which you can assign a quantitative value that distinguishes two given steps. Intuitively, it makes sense that the Brazil string with an S is very close to the Brazil string with a Z, right? And not so close to the Peru string. And there are different algorithms that basically do different permutations and count the number of characters and different sorts of things that I will not try to explain because I don't understand them. But intuitively, it makes a lot of sense, right? So we can use this idea to help us with the join. Let's see here the string-dist matrix function of the string-dist package. So what you can do is provided with 2 vectors, and here this is just the method, the algorithm that's going to use. And what it does is that it creates this matrix in which you have the distances between the given steps. So Chile and Peru are like, there's a number 5 of distance between them. Chile and Chile is obviously the same, so that's a distance of 0, then 32 and 5. So let's take a look at Brazil. So 6, 5, 30, and then 1, right? This is very close. It makes sense that the algorithm says it. The same goes for Peru with an accent and without an accent. So we can use this to create a join, right? We can identify the lesser value in each row and use that as a match. The problem is that in this example that I obviously created to not work, it doesn't work perfectly. So Venezuela in the Spanish common spelling and the official UN name, like it's quite different. So basically here, the minimum distance is 7 for Peru and Brazil. So that's not good, right? The algorithm is not it's not identifying the correct one, right? We know that it's Venezuela. We could try to use a different algorithm and a ad hoc expression too, or regular expression too. But it can be like hard to do when you have 500 of these mismatches, right? It can be hard to do the tracking by hand. There's an R package called fuzzy join, which makes using approximate string matching in joins very straightforward. So basically, you use a very similar syntax to the one on dplyr, and you have these 2 data sets, the ID variable, and it provides you with the join according to the different matches that we just saw in the matrix, right? Without even having to touch the matrix. So it works with Brazil, it works with Chile, it works with Peru, and with Venezuela, it doesn't work because it's got a threshold of this, right? So anything above 2 will not work. In this case, we could have changed that, but in this case, it would have been, you would have to correct it somehow by hand here, no matter what. So what can we do about Venezuela? We know that human supervision would help a lot. Like you can see that Venezuela and the long name are basically the same in human eyes. That's also true for like names. Like when I work with politicians' name, like it's very clear they are the same, but for some reason they're spelled differently, or they have like a middle name in between, and that mixes up everything. So what can we do? And faced to this problem, like basically every week, working with observational data, I came up with this little R package called Inixa, which is an RStudio add-in that is a graphical user interface that aims to reproducibly supervised passively, or it helps you at doing. The package does not implement any algorithms that string this job. I'm not touching that. It only provides a graphical way to supervise them, to review them, to revise them. And it serves as a coding assistant without ever modifying the R global environment by itself. I think this is very important for graphical user interfaces in programming environments. Like, you don't want it to become like a graphical user interface in itself. You don't want it to be Excel. You want it to help you build better code. So the output of this add-in is just code. So in the end, what you're doing is completely reproducible because you've got code to save in your script. And just comparing it with some other tools that I found, I think that one of the advantages is that it works within a programming environment. So I'm just coding and I can fire it up. There are some other great tools that work within OpenRefine and Excel that can do similar things. But yeah, it's a problem to like having to save the data set, open up this other program and save it again. You probably don't want to do. So how does Inixa work? This is our data again. Just to remind you, like, this is the big problem, Venezuela. And we want these to match, right? So this is a window you get when you fire up the add-in. So so the first thing you see is the settings panel, in which you can establish the different parameters of the join. So you can, in this case, we're going to do a left. We're joining these data sets by this ID variable, and we're going to do a left join with this distance algorithm. And when you click next, this is the important panel, the review panel. What you see is basically a collection of the different inexact matches that the algorithm found, right? So in this case, Chile is not even here because that's a perfect match. The algorithm knows it's a perfect match and you trust it, I guess, because it's the same string. And you get the ones that are not perfect. In this case, Venezuela, Brazil, and Peru. And you get by default the value that was closer, right? So in this case, for Venezuela, it was Peru. For Brazil, it was Brazil, and for Peru. So what you can do is that you can manually review them and change them. You can also get that to a missing value. And in this case, we're going to change Venezuela, of course. And here we have our final review panel. And when you click next, this is not doing anything in your R environment. You just get code. And the code is basically following dplyr syntax. And what it's doing is creating this, or it has this custom match algorithm. So first it's got the approximate string matching method it's using, and then the custom match that you are changing by hand, right? So Venezuela in the left-hand data set, it's now Venezuela, Bolivarian Republic of in the right-hand data. So that's it. It's just code. You can then execute it, and it's going to perform the match as you would expect. That's all it does. It's a very simple tool to help with a very specific problem, but a problem I face a lot. So this, I hope it can be useful to some other people. There's also an argument here to provide more information. So you can choose to get these other variables that tell you what was the match, what was the distance, and whether it was a custom match. So whether you overrode what the algorithm said. That's the core of the package. That's what it's doing. I have a few concluding remarks. Of course, graphical user interfaces are convenient and time-saving, and usually they're pretty straightforward. But they're like, when you think of them, you don't usually think of reproducibility, right? When you think of Excel or something like that, there's no way to record what you're doing. So you might be a little bit like not sure about something like this, but I think they can be helpful in reproducible workflows when they're served as coding assistants, just like helping you build code and nothing else, and the code is reproducible, and that's what's important. An inspiration for this package was Questionnaire, which is a package that offers a very similar workflow for recording values, reordering factors. I really recommend it. And it also like does nothing to your environment. It only gives you code, and it's pretty easy to use. I have a long to-do list for this package, more testing, better documentation, a better interface would help to increase performance, new functions. So one thing I would really like to implement is the ability to join by more than one ID variable. Now you can only do it by one. And in some cases, like maybe like you have two ID variables, but one of them you're sure it's right, so you don't want to use the approximate string algorithm with that one, approximate string matching algorithm with that one, but you want to use it with that one. So yeah, that'd be pretty cool. And of course, all feedback is very welcome. And thank you very much. This is the link in which you can try the development version of the package. Thank you.
Thanks, mate. That was really interesting. And you actually addressed a lot of my questions about the add-in and things like that. So that was really helpful. If anyone has any questions or comments, feel free to add it into the chat. Everyone's asking, do you use Shiny? Is it Shiny for the GUI?
It is Shiny, yeah.
And so, I mean, while people are thinking of their questions, I'll start. Is it to create this? Is it it's a Shiny development process?
Yeah, actually, when I first coded this, I was learning how to use Shiny, so I should say it's not like very hard if you know like R. And yeah, it's Shiny, and the process from Shiny to an RStudio add-in is very straightforward. Like if you got a Shiny app, it's very easy to turn into an RStudio add-in. That's very easy to call from the regular IDE.
How would you recommend? What's your recommendation for folks wanting to get started with Shiny if they're brand new? They've got a bit of R Markdown, they've got a bit of R. What's your favorite on ramp?
I remember watching a very nice user presentation on Shiny. That's what got me started. I can look it up and send everyone the link. Yeah, that was very good. I prefer those sorts of things. I'm very like millennial, yes.
Yeah.
Yeah, videos are pretty interesting.
David Rios asks, are the methods tied to string best or is it possible to add a custom user generated function?
Oh, that's a very good question. Currently, yeah, they're only tied to string list, but potentially you could use any custom function. Like, I don't think it would be that hard to get into the interface. You just need something that builds a matrix, right? Like one of the matrix we just saw, and it should be very straightforward. Yeah, that's a great idea. Sometimes you need to do ad hoc things to parse some variables.
That country names example that you brought up was yeah, a bit it brought back some memories for me. There's such a difference between some of the official names of these countries and what we call them commonly. Florence, like just to expand a little bit on the is it possible to find matches based on more than one variable, for instance, like fuzzy join?
So first, I'd like to address that with the country names. There's a very nice package called Country Code that I would recommend if anyone's dealing with that. It's very nice. I don't think it provides like approximate string matching, but it has like a huge list of all the different ways countries are named, and that's usually very helpful. Regarding Florence's question, currently no, but it's something that I've got on my to-do list. It's something I would like to implement because it would be very helpful. Yeah.
Florence, you must have some horror stories from your work. By way of back, sorry, Florence is a PhD student at Canada at Montreal, and put together a large data set of politicians here.
Yeah, and I mean, I was asking the question because more recently, I was trying to match data sets that had names of places, but were not always written the same ways. And also they had addresses, and the addresses weren't always spelled the same way. Sometimes it was written street, and then sometimes st, and then anyways, it was really it was a mess. And fuzzy join didn't really work perfectly because sometimes it matches the same thing with more than one observation from the other data set. I mean, so that's a problem because you're like introducing mistakes. So I'm really happy to try your function. Thank you.
No, thank you. Yeah, it's such a common problem to me. Yeah, politicians' names are always like the main file system.
Does anyone else have any other comments or questions? How much time do you think it took you to put together? So for instance, if I got a grad student, is it an appropriate summer project if they don't have any Shiny?
Definitely. Yeah, I would think so. It's somewhat tricky to learn first because especially if you are like very used to the tidyverse and pipes, like at least the regular Shiny interface does not use that, and it's like a whole different thing. But overall, I think it's very feasible for a summer project.
Any other questions?
I have a comment first. This is amazing. And I have a bit of a question. And the question is, have you found it, does it get cumbersome with a lot of text data? So for instance, like I lived the country name debacle in my research. But that's easy to fix. Like there are I don't know, 100 something, nearly 200 countries in the world. If you had to do it manually, it's fine. What happens if you have millions of text observations? Do you find the interface becoming a little bit too cumbersome? Do people have to scroll down? Do you have like an idea of I don't know, like have you tried it out on a text data with like millions of possibilities and a ton of misspellings? And so for instance, like instead of country names, villages in Brazil or Chile or anywhere, because those are usually in data sets frequently spelled in different ways. Have you noticed, or people using the package, have you gotten feedback in terms of like how manageable it becomes? Because I think it's a lovely idea to be able to just kind of scroll down and manually control some of those inexact matches is perfect. Have you gotten feedback from anyone in terms of what it feels when there's like literally millions of entries to choose from?
Yes. One of my, I remember someone working with actually Brazilian municipalities, and there's a lot of them, probably a few thousand. If there are too many mismatches, currently it crashes. But I need to work on a better way to handle like that. It definitely depends on like the number of mismatches. It doesn't really matter that much, like the overall number of values in each variable. But if there are many like discrepancies in the algorithm, like huge distances, it's very cumbersome. One thing that I've been thinking about implementing is trying to like saving your progress in a way, because like as you say, like if you're reviewing like 10,000 of them, like you're probably not going to do that like in a few minutes. So I've been thinking of a way to maybe like being able to call the add-in from some code that you have, like a code with all the like the final code that it produces. Like let's say that you could select that and call the add-in, and it goes back to where you were. that'd be something very useful for those use case. But yeah, it's always a concern when you have like these huge data sets with a lot of discrepancies. I would very much like the package to work better in those situations. Currently, I mostly use it for like a small or mid-level data.
Thank you. It's a wonderful package, by the way. It looks great.
Thanks.
Monica apologizes to you, Maria. I'm not sure if you saw that in the chat. Are there any other questions or comments? I think it's a wonderful idea. I can really see this approach increasing in popularity. Did you write like a blog post or whatever about like how you did it, or are there steps? Oh, yeah.
Not yet. Yeah, that's a good idea. Yeah. Yeah, hopefully it can help people. Yeah,
and also it might like help with some people get intimidated by like the idea of writing a package, right? But if you're sort of writing, I appreciate it's not a wrapper around a package, but it's an easier way. It might be a nice way to motivate some students who might feel more comfortable with that rather than making packages.
That's true. In a way, you only have to deal with like the functions, but not really with I'm not implementing any algorithms here or doing any statistical computing.
Yeah, and also a nice way to motivate them to learn Shiny, right? You could make an assessment around building something like this. Would be cool.
Yeah, I'd be very happy if anyone wants to get into the GitHub link and submit issues, look at the code. I think it's relatively simple. It could be better documented, but I
think that's like a perennial comment. We've got a minute or two left. Does anyone else have any other questions or comments for Andrés?
I've got one. I guess I really appreciate how the package, or like you can interact with this GUI, and then at the end you can get the little code snippet for what you would actually use in your code. I think just for teaching purposes, I think something like that could be really nice, because not everybody has great visuals for working with relational databases or doing joins. And so I think it's nice to be able to have a more user or beginner friendly approach to doing it, and then seeing what code it would take to produce that. So that's pretty cool.
Thanks. I really recommend this questionnaire package, which is for like recoding values and reordering factors. Like maybe something like even like for teaching, I guess it could be like, I actually teach it I teach it in my class. It's like very nice. Sometimes you have to record like a lot of things, and it's way easier to do it in that way, but it's still reproducible, right? You get the code, which is great. Thanks.
Coming up to 11:30, so we might just say thank you once again for introducing the add-in, and I think more broadly for giving us this idea of even doing this. It's a wonderful idea, and thank you very much, Andrés.
Thanks, everyone.